And welcome back, everyone, to Sophia Room. So with us now, we have Maria Arias Dominguez, and she is joining us from Seville, Spain. How are you doing today, Maria?
Hi. Well, it's a bit hot here, so I have the windows open. So maybe you hear the dogs barking from the neighbor, but that's fine.
That's a good addition to the call, actually. If we can get some nature kind of sound, so that's great. So Maria is a Java champion and a senior software engineer at Red Hat, and she's going to be talking about data flow in the easy way. So without further ado, I'm going to give the stage, or in this case, the stream to you, Maria. So free to go.
Thank you. So yes, what I'm going to talk about today is about camels, more concrete about Apache Camel and the family of products or software projects that are around Camel. First of all, who am I? Oh, I'm Maria, obviously. You may have seen me in other talks like We Kill based on metadata or how to survive a zombie kitten apocalypse using free and open source software. And well, I have been free and open source advocate and true believer of this is the way software should be since forever, since I met it in the university. I studied computer science. I started in the geospatial world. So I started doing location maps, path calculations, like when you are on your GPS and you want to go from one place to another, how to calculate the best route. And at some point, I got involved in open source communities. I ended up being, for 2 years, the OSU president, and a couple of years back, exactly a couple of years ago, I joined Red Hat, in which I abandoned a bit the geospatial area and started to work with integration frameworks and Apache Camel in general. So what is this Apache Camel on integration frameworks I'm talking about? So imagine you are starting a new project, a new software project, and you're starting to design the architecture. The first thing that you usually do is create these UML diagrams, and you start thinking on how to make different components interact. Like I have a module that connects to a database, then I have to push something to an API or collect something from an API. Or maybe you have to connect to some external FTP. Maybe you have to interact with, I don't know, some Salesforce or ServiceNow or any other component that is external and special to your use case. So you start defining these UML diagrams and you start defining how the data is going to flow from one component to the next, and the workflows, and maybe your workflows are have some conditionals or some loops, or maybe you need to interconnect two pieces that are, well, they don't interact directly with each other, and you need to place some software, some glue in between that will connect one piece to the next. And that's where integration frameworks enter your architecture, or should enter your architecture if you want to keep it decoupled and easy to maintain. So this glue between components is what integration frameworks are. They try to simplify how different components interact in a way that it's as decoupled as possible, of course, obviously. Each use case will have their own data models, will have their own specific workflow on how the components will interact. So it's not completely decoupled, but it tries to decouple as much as possible and tries to abstract you from the specifics on how to interact with each component and focus on your use case and your what exactly do you need from one component to the next. And they also try to make it easy to maintain this this code you have to write, because if you can keep the source code of these little pieces small, if at some point you need to replace them, or you need to replace one component and add a different one, for example, you want to replace a MySQL for a PostgreSQL, or you want to replace an SQL database for a non-SQL database, or maybe now you want an Elasticsearch. Maybe it will be simple, maybe not if you have your custom source code, but the idea is that with integration frameworks, you can very easily plug and unplug components. So it's not as painful to adapt your architecture to all these new changes. Also, the idea of these integration frameworks is that you don't need to know the details on how each component act. For example, the same way that if you are interacting with a database in Java, you usually use Hibernate, so you don't write very complex SQL queries, but you rely on the classes and the DAOs and all these facade models that hide a bit how the database interacts, so you can easily replace one database with another. The idea is that the integration frameworks allow you to do something similar. So the pain of how to implement your use case is not so much, because you have a lot of things hidden. There's a lot of things that are happening automatically, converting from one data model to exactly what this component needs, that you don't have to care about. And if I said, if at some point you replace that component with another, the idea is that the integration framework will be smart enough to be able to do this without you having to redo all your workflow or all your data model. A good integration framework should have a couple of interesting things, like they should be able to allow you to implement these workflows of data and implement conditionals, or implement loops, or broadcast. Or for example, maybe you want to split into different flows because you are iterating over an array, and then you want to merge those flows again into a single flow of the software program. Or maybe you want to do a bit more advanced pattern in your workflow. These are the enterprise integration patterns, and you can look for them. They are very well defined, like the software patterns, software implementation patterns, or design patterns. And once you start learning about them, even if you are not using yet an integration framework, you realize why integration frameworks are important. Because the same way software integration patterns give us a lot of abstraction tools on how to implement properly software, the enterprise integration patterns give us tools to abstract how to implement or how to design workflows in a way that is cleaner, let's say like this. So what I'm going to talk to you about today is Apache Camel, which is a free and open source integration framework. Is the most active project in the Apache Software Foundation at least for the past 2 years. And it's one of the most used integration frameworks. It's hard to say it's the most used, because it's hard to get statistics of what people use on their private implementations, their closed source projects. But let's say it's one of the most used, and it's one of the is the most active on the Apache Software Foundation. So you can be sure that if you use it, you are not going to be alone using it. So there's a lot of people that can help you, that you can hire as consultant, that you can hire as technical support, there's a big, huge community around it. How does this Apache Camel work on the inside? Well, this is a very rough design of what Apache Camel does on the inside. It's obviously it's more complex, but the basic idea is that you have different external systems. So you connect through endpoints to these external systems. Maybe the endpoint is writing something on the external system, maybe it's reading something. Usually it's a mix of both, because if you're reading something, it's because you first write a request requesting that thing you're reading. Then the endpoint generates what we call an exchange, which is a datagram, a message that contains all the information extracted from the external system, and also information on the context of where in the workflow you are. Like, this is the first step, this is maybe when I contacted to this external system, instead of data, I receive an error, an exception, then I store that error. Maybe I received data, but also I received more context, some headers giving context to the data. That's also on the exchange. The exchange goes to a router, which is the one who has all the logic of your workflow, so decides what is going to be the next step, which, as in this case, it's split in two, so it goes to two different endpoints. It could be, maybe it could be the last step, so the router decides you already finished. Maybe it's not sending to an endpoint itself, but it's sending to an intermediate step that what does is a transformation. What do I mean by transformation? Well, the endpoint is receiving a message that is the output of the previous step. But maybe you need to change that datagram so it's not sent as is to the next external system. Maybe the output of the previous step is an XML and the input you need is a JSON. Well, then you need to convert the XML to a JSON. Or maybe you need to trim some of the attributes, or maybe you need to change some of the attributes. So that could be an intermediate step that is not an endpoint, but the idea is the same. The router sends it to this intermediate step that is a transformation. Then the transformation generates a datagram that is sent to the router, and then the router decides what is going to be the following step. Apache Camel has more than 350 different types of endpoints. What does this mean? This means that it knows how to interact with 350 something or 60 something different types of components. This type of components could be from databases, or maybe you want to create a Telegram bot, maybe you want to interact with Twitter, maybe you want to interact with a REST API, maybe you want to, there's more components than you can imagine. There's probably, if you check the list of components, there's a lot of components you didn't even know it existed. At least that happened to me. Then the idea is that this is, of course, very roughly how the architecture of Apache Camel is on the inside, but the idea is that you can focus on selecting which endpoints and which transformations you need to perform your integration in your workflow. And you order them step by step. You decide the conditionals. The router can decide, for example, if depending on the response, the exchange that is incoming, it can decide going through one flow or the other. And you can focus on just defining these steps. And Apache Camel makes it very, very easy to define these steps because it has a DSL, which is a domain-specific language. And it's not natural language, but it's very, very similar to a natural language, or at least for me, it's very easy to understand. And of course, if you are a software developer, you will get it very fast. So an example of this, how would be a hello world in Apache Camel? Well, one of the things Apache Camel allows you is that, or one of the features I like most is that it allows you to write the same thing in different ways. For example, here you can see the same hello world root or integration in JavaScript, in Java, in YAML, and XML. And it has a few more languages, which I don't remember. But as you can see, the difference between the JavaScript and the Java is just, I mean, the code is the same. It's just the Java decorations you need for this is a class, this is the imports, this is the package, which is needed for Java. But the pure code is going to be the same in JavaScript, in Java, in Groovy, in whatever you use. And of course, in YAML and XML, it's not exactly the same because YAML and XML are not programming languages, are description languages. So instead of a function that starts with from, you have to define the from, or you have an element called from. So let's take a look on what this means. This is a hello world, which runs every 1000 milliseconds, which runs every second, and prints a hello world in the log. So it starts from a timer that is going to execute this integration every second. As a first step, you may have something like this, which is a timer, which is something you can, instead of defining a timer in milliseconds, you can define a cron. But you can also have something that is listening, like, for example, you can be listening to a RabbitMQ or a Kafka stream, so a Kafka broker. So you are waiting for some message, and the moment this message arrives, then the integration starts. So depending on your use case, you may be willing to use something like a cron or a timer, or you may be willing to use listening to something. So here we start with the simplest one. Every second, we define a message called, with the message hello world inside as the body, and then we send it to the log. In YAML, exactly the same. You start from a timer with 1000 milliseconds, then the following steps are first, the body is going to be this string, and then you send this body to the log. So this could be like a transformation step. You can consider it. It's not really transforming anything, it's overwriting whatever was there, which was null, but it's like a transformation step example. And again, in XML is exactly the same, a from, a set body, and a to following step. If we had a more complex example, like we had more steps, they will be like this to log info step. So you, in the following line, you write another to and define which is going to be the following step. Also, these strings that define each step have their own language, their own semantic. So the first string that appears here, the first word, is telling you which is the component you are going to call, in this case, log. Then you have 2 points, and then you have, usually is like If it's a database, it's going to be the name of the table. On this case, it's going to be the name of the log. On this case, it's going to be the ID of the timer, in case you need an ID on the timer. The idea is that this next string is going to define exactly, first is the component, then it's like the ID or the context of exactly this component where you're going to use it. And then you have parameters, infinite parameters. As part of the exchange of the datagram of this message that goes from one step to the next, you can have headers that can give you context like username and passwords. Maybe you want to extract them somewhere and add them as headers. You can have the body of the message. You can have properties or attributes included that are not part of the body, but are attributes you can use from one step to the next to store maybe some intermediate step that you can use later. So it's very, very flexible and it's very easy to understand. Once you understand these 3-4 basic things, like you start with a from, then you go to varied number of 2 steps, and then the semantics on what this string means, then it's pretty easy to understand even if you don't know the workflow, it's very easy to understand it. This will be an example of what happens if you want to do a conditional. So instead of a to or a set body, you say, I'm going to start a choice. If this condition, then do this. If this other condition, then do this. Else do other thing, and the conditional. If I didn't explain it to you and you just read the English there, it's fairly easy to follow how this works. And the loop will be very similar, but instead of a choice when, then it's going to be looping here and ending the loop. So one of the things people ask me when I start explaining what Apache Camel is that Apache Camel is nice, but it runs on Java. I don't like Java. I agree with you. Java may not have good fame in as a tool or as a lightweight framework to use. Well, first of all, you don't have to develop anything in Java, even if you use it, even if you use Camel, because you can define your routes in JavaScript, for example. You don't need Java. But yes, once it runs, it's Java. Camel is surprisingly lightweight and fast for Java. If you run it, you will get, it has a low memory footprint, it's fast, it's lightweight, it doesn't have many, it's not heavy as a library. It's very, very light, but still it's Java. And probably if you're looking for something serverless or something that you start and stop quickly or something that you need to be very, very, with a very, very small memory footprint, it's not what you're looking for. Don't worry, because Java is evolving a lot. I don't know if you have heard about GraalVM and Quarkus and all these new trends in Java, but they exist and they are there. And we have Camel Quarkus, which is a flavor of Apache Camel that runs over Quarkus. What is Quarkus? They call it something like supersonic, subatomic Java something. But the idea is that the memory footprint, you have to compile Camel Quarkus specifically for Quarkus. And it runs not on a normal JVM, but on a specific Quarkus JVM. And the idea is that it has this concept of closed world. So it cuts a lot of code that knows that is not going to be used. It optimizes it, it makes it faster, it allows you to compile better the Java code in summary. So the idea is that now it starts in milliseconds. It's like a bash script. You just run it and it's running. And the memory footprint is negligible. I mean, you don't see it in your memory. It's really, really, really small. So we have improved this because, well, it's Java, but it's new trending Java, which is very fast and it's very lightweight and it doesn't use, it's just a minimal memory. It's comparable to a bash script, really. So, but the idea of this has a problem because Camel Quarkus is Knative. It's based on, it runs on Knative, which is, maybe it's adding complexity to your stack because now you need a specific JVM, you need, well, good thing is that we have other tools to simplify your development here. Because maybe because you're not familiar with Java, maybe because you're not familiar with Quarkus, maybe you don't know how to handle this from a DevOps side. Don't worry, we have Camel K. Camel K is a toolbox, maybe, that allows you to easily deploy Apache Camel Quarkus fast and quickly. I mean, you have a command line interface, you have you just write camel run this JavaScript file that contains the definition of my workflow, and it deploys it on a Kubernetes cluster, or camel log my integration, and you see the logs, camel delete my integration, and you remove the integration. So it's fast, it's easy to use, it's nice. What else can we have? So now our lives looks very good, but still there are things that, because sometimes the problem is that your integration or your workflow is not even defined or written by developers. So even if for a developer it's very, very easy to define all these steps, maybe a data scientist or maybe someone who have to write complex workflows and sees that some of the steps can be refactored into a meta block, maybe. So instead of writing always these 5 steps one after the other, I can write a meta block and use 1 step instead of 5. That's where Comelets appear. So the idea is that Comelets simplify even more how the Camel DSL, how Camel is defined. So instead of having to write your integration with a lot of small steps, you can do it with 1 step or a couple of steps. So it simplifies even more the maintenance of your code. It simplifies even more the how your workflow creators work. Maybe you have some developer that creates these meta blocks because they know, for example, every time we receive a new document from this API, we need to certify that this document is valid, analyze it, send an email to someone, store it in the metadata in a database, store it in this FTP, blah, blah, blah. I just create this meta block, and my workflow creators use that meta block, and then they can create different workflows for different types of files, but this meta block will be the same for all of them. So it simplifies the maintenance. And I'm going to show you a bit more of code. On this case, I'm going to show you how to add a transformation step that is not as easy as the transformation step on set body that we saw before. This is also going to change the body, but it's going to generate random strings. So on this case, it's going to say hello to a random name. And as this is a random thing, I need some piece of code that generates random names. So I create a processor, I define how this random name is going to be created, and I add this processor here instead of the set body hello world. The beauty of this is that my workflow is still defined in maybe one line of code per step. It's simple, it's pretty easy to understand what this is doing. If instead of processor, I call it hello name or setup name or whatever the use case makes sense to a semantic to name it. Yes, the processor is 10, 15 lines of code, but the workflow is still defined very easily. So if I'm looking for bugs, I can very quickly see if the bug is in the workflow or not, because I can quickly understand what are the steps on the workflow, even if the steps are a black box right now and I have to check that black box separately. But it's very easy to, if instead of a random name now I want to get those names from an API or a database, I change the processor, but the workflow remains the same. So you see, I decoupled this a bit. Maybe quite a stupid example, but it's very easy to see how this decouples your specific implementations, the workflow itself, the workflow definition itself, and the external components. If instead of sending it to a log, I want to send it to a RabbitMQ message stream, I just have to change the line that says to log info and say to, or Kafka something, to Kafka something. And it's very decoupled. The processor doesn't change because I changed the log for a Kafka or a RabbitMQ or a database. The previous step doesn't care what the next step is going to be, because really it doesn't matter. I know how to, it's like Lego pieces that I can just change the order and they know how to fit one with the next. It's pretty easy. And if I have to change one and add a different one, I can do it because Apache Camel knows how to make these connections properly. You have to give the semantic, the content of the message, but how the message flows from one place to the next, Apache Camel handles it. So on this example, what it does is querying a weather service, online service that is, it has a free quota. I don't know how many, but you can test it. And I'm going to query every 1 second, because if I don't give any parameters to the weather test, by default, it's going to be 1 second. And I'm going to first query this weather service and then log the response. And the response is going to be this, which is the response from the weather service. This weather service is one that is, it has a component in Apache Camel, and I thought it was easy. But the idea is that if instead of querying this weather service, you want to query any other weather service, you just have to change this line of code and the workflow will still work easily. If we want to do something more complex, or we want to start with something that is not a timer, we can use, for example, the example of Telegram bots, which I love because it shows one of the beauties of Apache Camel. Imagine you want to write a Telegram bot. At this point, you have no idea how Telegram bots work. So if you wanted to do this with Apache Camel, you will discover that first you have to register to create a Telegram bot. And then you have to interact with an API, a REST API. I think it's an API in Telegram. And you have to handle the Telegram token, chat IDs. You have to handle who is doing sending and receiving messages. And you have to learn how this API works. If you do it with Apache Camel, yes, you still need to register and create your bot, and then you will receive this authorization token, and that's it. You don't care how the API, the Telegram API works. You don't care. It's completely hidden from you. So, you know, you see an example and you see that what this does is I'm listening. So whenever someone talks to this Telegram bot, I'm going to process the message, return something based on this message. And this is where the logic of my use case or the specific of my use case will lie. And then I return the message to the Telegram bot, and the Telegram bot answers. And this works. And 3 lines of code plus whatever your logic for answering the bot is. And this means that you really don't care about a lot of the specifics of the components you have to connect to. If at some point Telegram changes their API, updates it, adds something new, you don't care because you just have to keep Apache Camel updated, and Apache Camel will adapt to those new changes. And unless you need to add something new as parameter like the authorization token, you don't have to change your code. If it was your own custom code interacting with the API, if the API changes, you have to adapt and you have to change your code. And that's time you have to spend learning and not only rewriting your code, but keeping tabs on the news on Telegram when they are going to change things. And also, you know, if the more code you write, the easier it will be that you add some bug or some security issue or something that shouldn't be there and you have to maintain and take care of. So if the more we can avoid writing and relying on some library that we know, or some framework that we know that is well maintained, is open source, it's maintained by big companies and small companies, but it's maintained by people that have the budget to make sure there are no security issues. It's going to keep updated. It's going to work. That's work you don't have to do. That's work you don't have to invest in. So this is completely decoupled. And if at some point you stop using Telegram, or you now want to add a different type of bot, and Camel offers, I don't know, in the future, maybe someone creates a Mastodon bot or someone creates a WhatsApp bot, which is going to be complex because WhatsApp is not very friendly with bots, but imagine someone creates that. You just have to change the first and the last line, and this same code will work because it's completely decoupled from what your bot does when receiving a string and answering. So you are decoupling, you are making it easier to maintain, you are writing less lines of codes, which means less bugs and less security issues. You are making your life easier and you are making your software architecture more reliable and more stable and more everything. This is an example on something a bit more complex. So this is a message queue, the MQTT, which is very popular among IoT devices. And if you use it, for example, in the Things Network, which is an open collaborative network of IoT devices, you get responses like this, like a JSON, whatever. So you can easily tell Camel that this response that comes from this step is a JSON. And you can say, Camel, parse this JSON and understands it. So when on the next step, I try to create a string for the body, content for the body of the message, I can use this kind of semantic or language to tell Camel that I want to use the elements, the name and the description in this case, of the body that comes from the previous step. This means that you are able to simplify even more the source code of your workflow. So you can, let's say it like this. Instead of having to handle XML and JSON and all these kind of things, of these kind of formats that are very common, and parse them and use Jackson libraries and all these kind of things, you can tell Camel to marshal and unmarshal this and just throw this kind of semantics to create and transform the message. So it makes it even easier to connect from one component to the next, because you can do all the transformations. So the input of the following component is exactly what it is needed. You can do a process like we saw on a few examples ago when you created random words and random names, but this is a way of generating bodies and handling the attributes without many issues or many complex source code. And I can show you more examples. I don't know if we have Q&A here, or I can show you more examples if you want on this.
We only have one question, but you can show the example, and I'll relay the question after. That's fine.
Okay. So this is on my GitHub, but it's there are many examples on how to use Camel, but I like this one because it is very complete and it uses Kafka in the middle. It's how an adoption, a cat adoption place would work or could work. So on one hand, you have cats coming to a Kafka stream and being stored on a database. And on the other hand, you have persons coming through a Kafka stream. And depending if there is a cat available or not, you will have a match or not. And if you start thinking on how to implement this, you're going to get a lot of different components, and now you have to model the database, and now you have to do a lot of source code around this, and maybe a component interacting to Kafka, maybe another component for the database. But if you see how this works using Camel, it's pretty simple. This is storing the cats on the database, and it just listens to a Kafka broker. I add a log. I send the Kafka message as a JSON. So on the following step, I can do a simple SQL using attributes on that JSON and store it on a database. And that's it. So the first part, which will be this one, is solved with 1, 2, 3, 4 lines of code, plus logs and comments. The second part, which is this one, and looks a bit more complex, and it is a bit more complex, but it's still only this part of the code. So I'm listening to a Kafka, I extract the name, I check if there is a cat or not. If there is a cat, then I update the cat and assign it to that person. If not, I just say, sorry, we don't have any cat right now. So we solved this workflow, which may be more or less stupid, but it's a real workflow with 4, 5, 20, 30 lines of code if we count comments and logs. And this is all the code we have to maintain. We don't have to maintain anything else. We just have to keep Apache Camel updated and it will work, which is something that it was very surprising to me when I discovered Apache Camel, that it simplifies a lot the source code you have to maintain. And I can continue showing more things, but if we have one question, let's...
Yeah, we have one question, but it's actually not directly related to the session. I think it's more of a personal opinion kind of question. So Ankur is asking, what are your thoughts on microprofile?
That's not a good question for me because I haven't used that much. I mean, I have used Quarkus as a user of Apache Camel and as a developer, making sure it works, the components work in Quarkus, but I haven't used microprofile. So I prefer not to answer that question.
That's fair enough. So we still have 5 minutes. So if you want to go deeper on any example, that's perfectly fine.
Okay, so I'm going to show you a couple more. I can show you this is just an example of like the one I showed that creates automatic names and send it to the Kafka broker. So I just wanted to show you that listening to a Kafka broker was here. Listening to a Kafka broker just says from Kafka, I say what is the name of the broker and what is the URL of the broker. And if I want to write to the Kafka, I just have to do exactly the same semantic here, but just add 2, and then Camel knows this is not a reading, this is a writing step. And if you're looking for more examples of how to use this, how to use Apache Camel, and they are good examples, I like to show this OpenShift integration. They are OpenShift focused, but they have good Camel examples. This one, for example, shows how to do a more complex workflow with more processes and more. In this case, it will loop over a CSV file. So it will loop for each row, and for each row, it will have a different stream, and it will query some XML API, it will process it, check a database, and in the end, it aggregates again all the rows and store the data in the database. So I didn't want to open that. I wanted to show that this complex workflow is, again, simplified. I have a lot of comments here, but it's simplified from line 40 to in 30 lines of code, including comments and blank lines. And all that transformation and I loop and everything, it's done here. So the loop is done by this split thing. And then I start streaming for each, creating a stream for each row in the CSV. So yeah, I read the CSV, I tell Camel this is a CSV, so understand it as a CSV, so Camel will know what are the rows and what are the columns. And then this split, as I unmarshaled it before, this split knows that it has to loop over all the rows. And then I process each row and I query an HTTP API, which is as simple as this. And then I query some database, blah, blah, blah. And in the end, I aggregate again all the rows that I split here. And here I have, again, one single stream that in the end store the thing in the database. And I think that's my time.
Yes, I was waiting to see if you wanted to talk anymore, but I would be interrupting you if you did, so we're better off this. But
yeah, I can talk for hours about this and show more examples, but yeah, I understand there are more people that want to share things.
Yes, we actually have another session in 10 minutes by Guy Royce on understanding probabilistic data structures with 100 plus UFO sightings. So gonna be interesting, I guess. But anyways, thank you, Maria, for the awesome talk on Camel. As I was telling you, we really expect to have you next year, but this time on site, on a room with people and human contact instead of
yes,
Zoom.
please.
Yes, I guess we are all waiting for the ability to do that. So thanks once again for the talk, and thank you for joining us today.
Thank you.